Hello class, I'm going to teach you how to calculate density using the water displacement method. First of all, you're going to need a graduated cylinder. You're also going to need a triple beam balance. You might recognize these tools from our scientific tools lesson when we talked about the tools we're going to use in the lab. So, when we're calculating density, we're going to use the formula mass divided by volume. We're going to use the graduated cylinder to get our volume, and of course the triple beam balance to get our mass. So the first thing is, when you're calculating density with irregular shaped items such as this, so anything that's not a cube or a square, it's considered to be irregular. So the first thing we need to do is get the mass of this. So if you never used a graduated cylinder before, the first thing we do is we are going to zero out the scale. So if you've never done that, zeroing out the scale is simply moving the weights all the way closer to the plate until it zeroes out. All right, once it gets on zero, we can actually start using it. So the way this works is we're going to utilize the one section. If it's too heavy for the single grams, then we're going to go into the tens, and then we'll go into the hundreds if it's heavy. I don't think it's that heavy, but anyway, we are going to put the irregular shaped item there. So I'm going to just slide this and kind of play with it. Notice when I put the weight on it, it's not at zero anymore. So at 10, it starts to move. And notice when I put it on 10 grams, it is roughly at about zero, which means this particular irregular shaped item weighs 10 grams. So if you have your notebook, you're going to write mass for this irregular shaped item is roughly about 10 grams. Now, because it is an irregular shaped item, we can't get a ruler and do like you would typically do in math if you had a length times width times height problem. So the way we do this is we take our graduated cylinder. You can put a select amount of water in here, not too much, because you have to drop this in and of course it's going to increase in volume. So what we're going to do is, a good number is probably about 40. So I'm going to come to the sink here and I'm going to fill my graduated cylinder up to about 40. I have a little bit too much, so I pour that out. All right, I didn't do 40, but this is 30. So now, in order to find my volume, I am going to drop this irregular shaped item inside of this graduated cylinder like so. So if you don't want a big plop, kind of lean it to the side. So if you notice, initially I had 30. Now, when I put my irregular shaped item in, I now have 32. So that means the volume of this item will be 2 milliliters. So I'm going to go to the board and show you, when we're doing the density for water displacement, how we get it and then how we solve for density. So if you take a look on the board, let's recall my actual equation is density equals mass divided by volume. Let's recall, on that irregular shaped item, our mass was 10 grams and our volume was 2 milliliters. So what I'm going to do is I am going to simply divide. We will be utilizing decimals on our iPads for calculators. Because we're in 8th grade and we take the STAR test, we can use a calculator. So I'm going to just do mine by hand because this is simple math. But you guys can put yours in the calculator. So I'm going to take the mass, which is 10 grams, divided by the volume, which is 2 milliliters. All right, I know 2 goes into 10 5 times. So my volume for that irregular shape item is going to be 5 grams per milliliter. All right, it is simple as that. I know you guys are at home and you don't have graduated cylinders, but I'm going to give you lots of resources so you can practice via online. And when we come back in person, maybe this will be something we get a chance to actually do in class. But that's the process of how you actually calculate volume with a irregular shaped item. When you're doing volume with a regular shaped item, which is going to be a cube. So I'm going to find a cube. And now, remember, the volume of a regular shaped item is just like if you were in math class and they told you to find the volume, you're going to use the equation. First of all, our volume is going to be, with this regular shaped item, is length times width times height. And I'll write that on the board for you in just a second. So here's my cube. All right. So I'm going to go to the board and I'm going to show you that equation. All right. So regular shape volume equation equals length times width times height. All right. Length times width times height. All right. So I am going to measure the length, the width, and the height of my cube, and I'm going to fill in the values. All right, so here's my cube, and if you know a little thing, anything about squares, we know our length, our width, and our height should be equal. So I'm going to go with centimeters, just because when you have centimeters, if I do centimeters cube, it's also equivalent to 1 milliliter. So if you take a look here, I'm going to go ahead and measure that, and it looks like my length of the cube is going to be 3, which also should mean my width should also be 3, and of course my height should be 3 as well. All right, so I'm going to have 3 as my length, my width, and my height. All right? So let's take a look at our equation for items that have a regular shape. All right? So I am going to input my numbers. So my numbers were 3, 3, and 3. All right? And remember, they all were centimeters. So I'm going to also have to multiply centimeters. All right? So if you utilize Desmos or whatever calculator, if you can't actually work the math out, I'm going to pull out my trusty calculator just so we could do this quickly. All right? So I'm going to put in 3 times 3 times 3. All right? And that's going to give me 27. So that's only half of the problem, guys, because remember, we are solving for density, not just volume. All right, so I am going to input my number. So now, just like I multiply the 3 times 3 times 3, I also have to multiply my centimeter times centimeter times centimeter, which is going to give me, you guessed it, centimeter cube. All right, because remember, 1 milliliter is equal to 1 centimeter cube. All right. All right. So now that we've done the volume for our cube, now we're going to get our mass. Because remember, in order to do density, we must have our mass and volume. A lot of students mess up on density because they forget to actually do both. You have to do the mass and the volume. You can't just stop at the volume. So we're going to come back over to our trusty graduated cylinder. Not our graduated cylinder, I'm sorry. Our triple beam balance. Because we're no longer using the graduated cylinder anymore, for the simple fact we don't have an irregular shape item. All right? So again, we always zero out the scale. And remember, zeroing out the scale simply means making sure it's on 0 before we actually put an item on there. All right? So I'm going to place my cube on the scale just like I did my irregular shape item. I am going to kind of slide this over to see, right? It's heavier than 10. So now I'm going to move to my 10 section. All right. A little bit heavier than 20. So I'm going to take it back a little bit to 10. Now the way this works, if it's still heavier than 10, I can come back up to my 1s to see if that helps. All right, so it's kind of moving. I'm going to take it over a little bit because remember we have to get it on 0 in order to get the correct mass. All right, so it's on 0 now. So if you notice, it's a little bit between the 4 and the 5. So when you do this, you have to add up your grams. So at the back, we had 10 grams, plus up here we have 4.5. So 10 plus 4.5 is, you guessed it, 14.5. So we discovered that on this problem, our regular shape problem, that the mass is going to equal to 14.5. All right, and that's going to be in grams. All right, so we're going to do the same process that we did on the regular shape because the equation does not change. It's going to be density equals mass divided by volume. Notice that I always put my units when I write my my equation and my mass and my volume. So that way, if you're working a problem, you know the units and they're there. So we're going to come back, and mass, remember, was 14.5 grams. And when we did our volume of regular shape, remember, it was 27. So I'm going to divide that by 27 cubic centimeters. All right? So now, we are going to put in those numbers. Typically, I have a lot of students who always want to put the little number in or the big number in first. It doesn't work like that. I know you guys remember T-bow, top in, bottom out. So whatever's on top, that's what goes on the inside. So in this case, 14.5 is on the top. 27 is on the bottom. So that means 27 goes on the outside. So we're going to come to our trusty calculator again, because remember, we're in 8th grade. So last year I know you did your work by hand. This year you do get a chance to use a calculator, so that helps you a little bit. All right, so I'm going to put in 14.5 and I'm going to divide it by 27. That is going to give me 0.054. So I'm going to write my answer is going to be, 0.54 grams per cubic centimeter. All right. So now I know the actual density of that cube and the actual density of the weight, which was an irregular shape item. So even though I utilized 2 different methods, I was still able to find the density of both objects. So the lesson that we'll be learning today is we're gonna be able to solve for density using the water displacement method and also solving for density for regular shaped items. So we're solving for density for irregular shaped items using the water displacement method, and we're solving for density for regular shaped items. All right? Now, your assignments in Canvas also assist you with this. If you need any help, feel free to send me a message or in the Zoom, just let me know or put a question in the chat. I'll be there to help. All right, that's Ms. Bradford's lesson on density, solving for irregular and regular shaped items.